effect on electric current. And the person who is presenting is Mr. Mogo. I've used PowerPoint and Kata, digital camera, and specs from Colorado University. Our objectives are the following. Those are the objectives. One is to state the factor affecting the strength of electromagnet. Two, to describe a simple experiment to demonstrate factors affecting the strength of an electromagnet. And we are going to start from our previous lessons, and I would like to know what is magnetic field from what we have learned from previous lessons. Anybody?
Space or region where magnetic influence is influenced.
Okay. That is the answer. Region or space where magnetic influence is felt. Number one, can you give me examples which we have magnetic field? One area where we have magnetic field. An example where you have magnetic field, or how can we set magnetic field?
Is magnetic field the same as a magnet?
No. So, yes. Where can we get magnetic? How can we set magnetic field?
Next to a magnet, we have magnetic field.
Yes.
So you need to have first of all, you need to have a magnet. So next to it,
There is.
you have magnetic field, or there is magnetic field around the Earth.
Is that what you want to say?
Yes.
Good. Another way we can set up magnetic field. Another one. There's another way we can set magnetic field. Yes.
By passing some current through a conductor.
Is it like that? What you wanted to say?
Something like that.
That's correct. Now, our today's topic will be magnetic effect on electric current. And we have one question there. What factor do you think will affect the strength of electromagnet? What we have seen those magnetic field, how can they be affected? Considering, let's first go back again a little bit. Can the first one with a bar magnet, can it be affected? Can we change the strength of the first one? How is it changed? Can we alter the strength of the first one? Yes? Ati?
It's already magnetized.
Yeah.
So it can be quite difficult.
Can we increase?
Not unless now you do.
Is there a way of increasing it? Can we
magnetize again?
Again, or can we reduce it?
Yes, you can reduce.
Yeah.
By placing it in the east-west direction to reduce magnetism.
Now, that brings our today's question. That is, what factors do you think will affect the strength of magnetic in the current carrying conductor? Now here,
I think since you had one, I think the previous slides, that one.
yeah.
The last,
How can you affect the second one?
even if you may have two of them, the two conductors, I think you may increase the strength.
Or is there another way?
Also,
Maybe by increasing the number of cells in the circuit. I can see a circuit there.
Can we look at that? That's what we're going to look at. I don't know what the answer is. Let's see this one. Sorry. Let's look at this one here. Please, what you can see around the bar of the magnet are what we call, can you see some lines here? This one, please. Can you see this? Can you see some dots here? There are marks around the magnet. That's what we call what? Magnetic field. Now, can you see them? Now, please try to observe them and you see what will happen. Are they visible? Are they visible? Is that a magnet?
Yes, since it has two poles, north and south.
They are only labeled, but is it a magnet?
Like us, don't know if there is any field.
Exactly. Now we can only demonstrate that one in the lab, but with the technology we can be able to use that one, and that is a magnetic material without field. But we can also show that we can be able to change the strength. Can you now, are they visible now? Now that is what? A magnet. And the other one is, we had was a magnetic material without fields. It is what? A magnetic material. With magnetic field, it is what? A magnet. Now, I would like you to tell me, this is the question now, how can we change the magnetic field in such a case? How can we change the magnetic field in such a way? What are the factors, what can we do to change the magnetic field here?
What is that?
Yeah. I would like you to tell me, what do you think is this one here? Can you see something running here up and down? Can you see something running? Can you see this running up and up, circling like that?
Like
what do you think it is?
It's like water bubbles.
Ah, that's good suggestion. Who else would think? Yes? Any suggestion? What is that running up? Yes? That's also a good suggestion. Yes?
Electrons.
Electrons, that's correct. And when you have a flow of electrons, it's called? We did also that one, it's called? Correct, that is a current. So when the current is passing through the conductor, what does it set? And we did the experiment, we did an experiment, a previous equation, where we passed a current through a conductor and we set what is called magnetic field. Now, how can we change the strength of that magnetic field in such situation?
I think if you increase, or you reduce the voltage, or you increase the voltage or the current, then it will.
I would like you to observe something here. Now, if you look at the diagram there, can you see the flow? Can you see the flow of the electrons, or what people are calling bubbles or whatever? Can you see the flow? What is the flow? Slow or fast? Slow. Can you see the dots? Can you see the magnetic field? They are very weak because the current is slow. If I increase the current, what happened to the magnetic field? What happened to the current now? It's fast. What about, can you see something visible more? What is visible around the coil? The magnetic field. So one way of increasing the magnetic field is to increase what? The current. Have you understood?
Yes.
That is one way. Another one, let's look at another way. Look at the strength of the magnetic field. Is it visible as before? How many coils, how many turns are there? One. See the strength? Can we increase the number of the turn, please? And we observe the strength. Look at the magnetic field. Is it more visible? Let me increase again. Is it more visible? What about now? Is it more visible than one? Huh? Now, what conclusion can you make from here, please? What conclusion can we make from that? Class? What can you say about the magnetic field with the number of turns? Yes?
I have observed two things.
One.
One, the number of turns of coils increases the magnetic field.
Exactly.
And number two, the magnetic field is also increased by the strength of the current.
That's good. And that brings us to...
It's okay, just click on it. Anywhere.
Our observations. Those are the observations. What did you say? When a current is increased, what happens? Did you observe that? Thank you. Second one. When the number of turns increases, then that's what we have learned today. What are the factors affecting the strength of magnetic field? One is class. Correct. Another one? Is that correct? Is that correct? What does it say? The number of turns in the solenoid increases. And the other one is what? The amount of current. And I want us, you do a project, and that will be the project. Mr. Kemen, can you do our project, which you shall do after the end of this lesson? Can you do the project which I want the class to perform after this class?
Design and construct a simple but efficient electromagnet.
That's good. That's what I would like the class you do before we meet the next time. Thank you very much for participating. Thank you.
Maybe to add on that, maybe you should allow students a bit more time to look at the pictures and maybe ask somebody or somebody to explain what it is that they are seeing. Because even me, I know I was looking at it and wondering what it was, and okay, it's a battery. Then I think the other thing is like a conductor, is it?
Conductor.
It's a conductor.
Yeah.
So, but you call it turns, which is a bit confusing to me, but maybe it's a word that you are using. But so maybe it would be good to ask students what it is that they are seeing before you continue. And then to make it a bit more student active, maybe also, you started off well by asking, you know about the magnet or so. I think you should maybe time it out also.
But it's also very important to really get in touch with the materials and to see how a magnet works and how you can really experience to funnel around, because you can explain how many times by a computer, with a computer, that you add coils on a cellular or remove them, but they don't experience it. They can see that it is there, but for the same matter they can also say,